try this. Okay, it looks like we're going now. Let's try this one more time and see if we can get this thing sorted out. It looks like we may actually have a stream going. So I'm waiting to see if this thing populates up here on the screen. Oh, okay, looks like we got something going. All right, I like it. Well, let me hide this. Let me fire up the iPad. That way, if there's any questions or comments, I can answer them for you guys. We should have something going here now. All right, let's see what we got here. All right, cool. We are live. All right, I like it. Cool. See if you guys can hear me. I'm going to know here in just a second because there's a little bit of a delay. All right, looks like there's one person watching, which is cool. I've got this set up because I want to talk to you guys tonight. What I should have done is I should have updated the, I'm going to hide this here, bud. What I should have done is I should have set this thing up and told you guys exactly what we're going to cover, but it doesn't really matter. If you got some free time and you're kicking it on a Saturday night, we're going to talk a little bit about multi-axis machining, and we're specifically going to talk mostly about fourth axis machining, but there are some other topics, and video is an amazing medium to tell stories and to communicate, and so I've always, for the last few years, I've always just done these broadcasts where I've just shot the videos, I edited them, but I really like this format where we can communicate. And technology's gotten so good, the internet is so good, the bandwidth is generally speaking so good that it allows us to do this. And so I can reach out and communicate with you guys. Looks like I got our buddy Aaron Powder from Australia is here on the chat. Hi, Aaron. Hope you're doing good. Hey, buddy. I'm glad to see you're doing good. Thanks for tuning in. So before we get started on this, you guys, I just want to let you guys know that what we're really going to be doing is we're going to be talking about a few different sources of machining, and so this is really one of them right here. And this is a small fourth axis. It's a vise made by the company Fifth Axis, and it's we're going to be doing some machining using the fourth axis of our CNC machine. And so looks like we're waiting for a little bit of this to transfer over. It looks like there might be a little bit of delay here. Man, I can see my stream. My stream seems to be dropping. Looks like we're losing bandwidth. Maybe I spoke too soon about the quality of the internet settings that we have here. Were you guys able to see any of that stuff? Because none of this showed up on my iPad when I went in over here. None of this stuff transitioned for me. Aaron, were you able to see that fifth axis vise that I was just put on the screen? That's okay, cool. Well, that makes me feel better because for whatever reason, it wasn't showing up. So that makes me feel better. Okay, cool. Then in that case, it looks like we're going to get a handle on this thing. Okay, so what we have here is the V75100X. This is the vise that I've used for quite some time. I bought this for a VF2 years ago. And it just turned out to be a really useful piece of kit. Now, there's some other things I wanted to show you guys. This is a little setup that I have going that I wanted you guys to be able to see. Let's see if I can catch this thing up here. And what this is just a little fixture. This is actually, these two plates right here were done by a guy that works for me. This is the mock-up for the fourth axis for my X7. And this is just a mounting plate for this vise. So we'll just go back in here and I'll show you guys real quick. We'll back this out. So this is just an adapter plate, and that is just an adapter. This part here is just a mock-up of the face plate or the mounting plate on the fourth axis that comes with my Silex 7. So we're going to put this stuff all back in place real quick. So one thing I want you guys to notice is that I have this little part that I designed here, and this is just a quick little demo part. And there's a variety of ways to program this. If you see, I've got this piece of construction geometry. If you guys don't use construction geometry, when you're in the design tab up here, you can just go over to construct and capture position, and you can choose all of these different options to create geometry that helps you design, design your part, understand theory, measure things. Construction geometry generally is used for reference, but it can be used for all kinds of things. What I did is I created this axis that runs down the center line of the part. Traditionally, when you're programming with on a fourth axis, it's really common, especially in high volume production, to just run your work offset. You guys can see that the X, Y, and Z is located right here on this axis. And this is a very efficient way to do it. Now, there are a lot of times when this, you may not want to do things this way, but it is a nice way to do it if you can. So let me slide this out here a little bit, and we'll do a quick simulate on this. So we'll turn this down. I know we're making contact. It's okay. I didn't set any boundaries. I just wanted you guys to see the tool. We're going to make this transparent. I just wanted you guys to see the tool kind of do its job. And we probably should just hid the fixture. Yeah, look at that. We're struggling here. I'm not sure if this laptop has the resources to run all these tool paths and do all the streaming and stuff like that. So this was just, as you guys can see right here, this was just too quick. Just a 3D adaptive tool path, and then a drill op where it comes up on the edge, and then it does a quick drill. Let's see if we can get this thing to run. Yeah, I apologize, guys. This thing, I didn't realize that my computer wasn't going to be able to pull this thing off in this way. One of the other things you can do, if you don't want to see the tool kind of bouncing around from top to the side view, you can come over here and you can go from a tool point of view, and it'll just maintain the tool's orientation, and then the part will rotate around just like it does in real life. And so, yeah, this kind of turned out. Let me see if I can get out of here. Okay, so what I was trying to do here is I was trying to show you guys that you can program right from the center line, and it's a very common, very easy way to do it, and it's probably one of the preferred ways to do this. Okay, so we're gonna jump back in here real quick, but if I'm gonna make a lot of parts, a lot of times I'm gonna try to work from the center line. Okay, if I'm gonna make one part, or maybe there's something that's got a really tight tolerance for location or something like that, then let's just say hypothetically that we are going to have to cut this part right here with a face mill, and then when we rotate up, let's just say that this hole right here, let's just say that hypothetically this distance is super critical, okay, like within plus or minus a couple of 10,000ths. Well, I actually might run two different work offsets, and I'll show you what I mean. I might run a work offset up here to cut my very first part, and then what I would do is for my next operation, I might just go in here. I'm just going to duplicate this real quick. And what I would do is I would then choose model box point. I would then choose this for my next one, and we'll just go ahead and set this as Z, yeah, model box point, like so. Flip Z. Why is it fighting us on this? Yeah, whatever. We set this to X. Model box point again, man. I am struggling today, you guys, but you guys get the idea. So what would happen is we would run operation 1 to face this thing off and put those holes in it like this. And then for op 2, we would take and we would measure off of our pre-machined surface right here to set our y-axis. That way we made sure we're just absolutely on size. There's other benefits in doing it this way. When you use multiple work offsets like this, probably one of the best parts about using multiple work offsets like this is that if your machine starts to heat up and drift over time, a lot of these C-frame machines, just like the X7 or maybe any of the Haas vertical mills, they have the bed down here, the spindle up here. As they heat up, that head actually grows, right? And so generally, my machines don't generally deviate too much in X, but they will deviate over time. If I start off the day, forgive me, I'm in America, you guys already know this, but if we start off the day and it's 60 or 70 degrees, let's say 60 degrees Fahrenheit, and it gets up to 108 or 109 degrees Fahrenheit over the day, there's no question about it, the machine's gonna grow. And running two different work offsets allows you to adjust that second operation to account for a whole location like this. Where if you were just running everything on center line, you may find that for whatever reason, it's just not the same. Just take that for what it's worth. I don't think there's always, there might be a best way, but there's always a lot of ways to skin the cat. And a lot of times it's more about accomplishing what you want. If you can make a part and you can check every 10th or 15th part, then you might do it one way. If you have to make the very first part perfect on the first go, then you may choose to do it a very different way, a little bit more methodical. By the way, as we're getting through this, I just want you guys to know that that this video is brought to you guys by the guys over at Sile Machine Tool down in Houston, Texas. They've been good to me. They've helped me create more time and energy to make this content for you guys. You guys know that I don't ask you guys to buy anything. That's just not what we do here. I don't have a vested interest, but I wanted to show you guys something that I thought was actually pretty cool. So two things. Number one, someone asked me about making large parts on the X7, and so let me get back over here into Fusion real quick. So this is a mold, and you can see this sketch right here is actually the travel limits of the machine. So you can see that I've got my tools that are darn near hanging out of the edge of this machine. It's barely in the envelope, number one. Number two, this big old mold plate, this is a mold plate that I made, and I'll just show you guys. It was actually a mold plate that I built a long time ago. It's was one of the first big jobs I ever did on the X7, and it turned out absolutely magnificent. But you can work to the limits of the machine. I just had to remove the tool setter, and while it's not ideal, that's what it took to get this job done when we didn't have a machine that was big enough. And so it is what it is. You guys have already seen this. I'm gonna segue right here. This is a part that one of the guys that drew up for me made, and he did it with the best of intentions. And keep in mind, when you mount one of these types of fixtures to your fourth axis, I know we're looking at it from the side, but it's going to rotate like this, okay? And so if you put this vise up here like this, what happens is that the farther you have to drill away from it, the more torque you impart into the vise. So you got to kind of find that sweet spot. You got to find the sweet spot where you can still reach your part, because you got to reach down next to this thing here, next to this vertical wall, but you also don't want to put too much torque on your part. Okay. And so with that said, let me show you guys, with that said, let me show you guys something that's pretty cool. You guys probably have already seen this before, but just in case you haven't, there's a company out there called DS Machine Works. Now, I've invested in 5-axis machines, a TRT 210 for one of our other machines, it's technically like a positional rotary, but it's capable of full 5-axis simultaneous machining. And this is something that I thought you guys really get a kick out of. And so I'm just going to hit this button. It's going to play a little slideshow for you guys. This is called the Moorside fixture, and they make them. I'll run it a couple more times. But what it is, it's an adapter that goes on your fourth axis, and it's kind of like like a manual spin fixture. And they have them in different sizes. You can head over to DS Machine Works. I should have put the link in the image. I literally just grabbed this image and put it in this folder for this stream. But as you guys can see, it takes your fourth axis from basically any machine tool manufacturer, and it allows you to run it in kind of a manual 3+2 type of fashion. And so it's super, I just thought it was super tricky. It was something that I just really wanted to show you guys. Multi-axis machining can be an absolute force multiplier. There's no question about it. To be completely honest with you guys, I find myself doing 3-axis machining like 90% of the time or better. I don't know, a lot of the time I do 3-axis machining, and we set the machines up to do the 3+2 or the 4th axis jobs or whatever whenever we need to do them. And for me, that's pretty rare. I would imagine that if we were job shopping, we'd probably do a lot more of this stuff. And I do see in the SAL user group, quite a few guys are starting to make some pretty cool parts. There's a guy in there named Piet that makes the coolest model airplane engines using a 5-axis X7, which is pretty cool. One of the guys in there, Rob, shortened the enclosure on his 4th axis and kind of like repowder coated it black. But there's a lot of really good applications. I'm not sure what YouTube will let me get away with. I would love to show you guys some amazing fixturing that I've seen for firearms. I have photos and videos of the stuff being made. I'm just not sure how YouTube's going to take it. And there's no question that when you get into 4th axis machining, being able to tag multiple sides of your part, whether it's drilling, pocketing, even engraving, it can really shorten your effort. It can reduce your kind of like time engaged with the part. So especially if you get it programmed and it's super automated. I hope you guys got a little bit out of this. This is one of those topics where I think you can kind of skim the surface a millimeter deep, but there's miles to the depth of this topic, and I mean miles. When you get into using probing for all kinds of stuff, for error correction, for in-process gauging, for making sure that parts are positioned appropriately in the rotary. I mean, the sky's the limit. Not only that, but when you start getting into machines that actually truly have 5 axes, not just the 4th, not just the A axis that rotates around the X, but when you get into a 5-axis machine, now you're talking about something called volumetric accuracy. And if you really want to scare your salesman to death next time, if you're thinking about buying a 5-axis machine, ask about volumetric accuracy. It probably gives most CNC machine tool salesmen nightmares. Anyways, with that said, let me take a look at some of these comments, and we'll see if we can wrap this up. I don't want to keep you guys here all night on a Saturday. So let's see here. I'm just gonna scroll all the way up to the top and get going. Glad to see Aaron's here. 5th Axis is a great company. I used one of their young sales guys from in Sydney. He met one of their guys. Yeah, they're good. They're good dudes. They make good products, man. I would if I've owned a variety of different vices. I've owned Kurt vices. I've owned Tagara vices. I've owned M-Lock vices. I've owned the 5th Axis stuff, and I'm a really big fan of it. And it's made right here. I want to say in San Diego, California, wherever you're at in the world. If you're in India, Europe, Italy, whatever, I'm a big fan of local manufacturing. I don't really believe that one group of people is better or worse at manufacturing than any other group of people on the planet, but I do believe that local manufacturing helps keep more of the money in your community circulating in your community. So take that for what it's worth. I guess that's me getting a little preachy. Someone says, looking at buying into Akuma M560. Any pros and cons since your last Akuma update? Love the Akuma. It's a great machine. Here's a couple things you need to know about the Akuma. Number one, it is a beast. It's like 18,000 pounds. I love the machine. It's an air hog. It uses way more air than an equivalent sized, for example, Haas, okay? So I think the Haas uses like 4 CFM. The Akuma uses like, I want to say 11. That's the first thing. The second thing is it needs a big circuit breaker, somewhere on the order of like 125 amps for 208 3-phase. That's a big breaker. We run ours on 480, and so we don't need as big of a breaker. Amperage wise, obviously, because we're running the higher voltage. And the only thing I can say is that there's a level of sophistication in the Akuma machines that can be a little daunting. The fact that you can operate the tool changer separately can be a little daunting. The Windows operating system, all of the, when you buy a Haas or like something like an X7 or like a Herco, you kind of get like this kind of like one flavor of a control, okay? When you buy an Akuma, your vendor, Gossiger or Hartwig or whoever, they set your machine up to like their standards. And just to give you guys an idea, an example, in some machine tools, in my X7, if I send it off to grab a tool, say I send it to go grab tool 10, if tool 10's not in the spindle, the machine doesn't know. It has no idea. It thinks it's there, it takes off, and it heads down to do its cutting, whether there's a tool there or not. The Akuma, it knows. And if you send it to get a tool that's like already staged with like an M6, like an M6, T6, it can actually hang up the tool changer. And so what Gossiger has done is they've written a custom macro for the tool change. So when I want to call a tool change on the Akuma, it's a G116. G116 tool 10 grabs tool 10. G116 tool 0 empties the spindle if there's an empty magazine pot. So just for the record. And so it uses quite a bit of air, uses quite a bit of electricity. Last thing, and I don't know why they do this, you have to manually grease the ways. Doesn't make sense. For such a high-end machine that's built in Japan, super rigid, just super high quality, come on, Akuma. Automatically grease the ways for us. So other than that, I love it. Let's see here. Can't wait to get my 4th axis running. How big of a jump is it from 3 axis? Vision Forge's asking. Sorry, man, I'm struggling tonight. It's not a huge jump. When you start to spin things around in a variety of different axes, what you'll find is that if you have error somewhere, it can get magnified quickly, and you can kind of get lost quickly. It's easy. Believe me, I've messed my fair share of stuff up. Just cutting a hole that's too big, or making a pocket that's it's out of position by a little bit because you thought you had the center line sorted out and you didn't. And so there are a lot of reasons. I think that programming from center line is probably preferred, but a lot of times it's easier just to set your G54 for op1 and then set it again for op2, and maybe set G55 and 56 if you need to. So I wouldn't be afraid to do this. Let's see here. Any technique for through slots in parts. When exiting the part, the thin material left behind wraps itself around the end mill. I'd have to see your application, but I can tell you that I haven't had big issues. There are things I guess we've never talked about. Like if you're using an end mill and you're just using like the end of the end mill, like you're using, let's just say a 1/2 end mill, and let's just say you're taking like a 100,000ths, like a 3 millimeter deep, a 13 millimeter end mill, 3 millimeter depth of cut, and let's just say you're going like 10 millimeters wide. When that end mill starts to get really dull, it'll start to leave like feathers. It'll leave like a nasty edge. And that's like the first telltale. For any of my tools, especially for the little ones that don't sound terrible, the first telltale that your tool's starting to, it's on its last leg is that you're getting, I call them feathers. When you start to see feathers, the end is near, or probably should be near. Yeah, I know, Aaron. That's why I didn't show some of that stuff. Y-axis lathe soon. Not for me. No, we're good. Believe it or not, we just made some pretty cool parts with our little stepper motor lathe. Someone says I've been training up on a new Citizen L20, and I'm amazed at how different the mindset is compared to a normal lathe with live tooling. Much different machining and programming strategies. Yeah, Swiss turning. I'm deciding if I should tell this story or how much of it I should tell. Okay. So most of you guys know that I make parts for the radio control car industry. That's what I do. I love it. I wake up every day. I love running the machines. I love dreaming stuff up. I love drawing stuff up. I'm incredibly proud of the fact that I make the majority of our stuff right here in California, where the vast majority of my industry imports everything from Asia. I got to talking to literally a legend in my industry, a guy that owned a company that made titanium components, and he's getting out of the business. And it's heartbreaking because when I think of I don't want to I don't want to like put this on blast for people that don't know who it is, but when I think of the name, when I think of this guy's brand, the name brand, it is just like, you just get the vision of just jewelry, just beautiful titanium components for RC cars. And it's heartbreaking to see it go away. But that stuff is all made on screw machines and Swiss machines, and there's we were having this pretty in-depth conversation here a few weeks ago, and he said to me, he said, Jay, I just love machines, man. I don't care if it's like baling hay. I don't care if it's like sorting grain. I don't care if it's cutting metal or making screws or, burning a hole in something with lasers. I love machines. And I would have to say that I 100% agree with this guy. I'm in the same boat, but it's tough. It's tough. It's getting tougher. As all of our businesses try to compete against other businesses from around the world, it's getting incredibly competitive, and we'll see how these things work out. I'm going to repeat myself. I've said it before, but business is just like racing. You can do everything right, and you still may not win, and you can do one thing wrong, and then boom, you've lost. So, okay. Well, so I hope you guys got a little something out of this. Let me show you guys this one more time. Oh, that's the wrong button. That's the overlay button. Apologies. We're going to get back to... I'm going to show you the Mooreside thing one more time, just so you guys can check this out, just because I thought it's cool. If you get a chance, head over to their website, it's DS Machine Works, and MORESIDE, Mooreside fixture. There's a couple of different versions. There's one with a quick release, like this one that has the knob on it right here. And then there's another one that actually just has like a nut on the bottom. And it's kind of like a Spindex fixture that you might use for like, I don't know, for like a grinder or something like that. And that's about that. So yeah, so that's it, you guys. I just wanted to make a quick video. I enjoy these chats. I enjoy this live streaming stuff. I do have a series of videos detailing the individual steps for loading a program, editing a program, running your program for the first time, recovering the tool changer, some of these other things for the guys at Sile asked me to make some content that's a little bit more dedicated to the customer base, because I know that a lot of you guys have questions. And so I'm going to do my best to make those videos. Probably won't see my face in them. We're just going to try to make them very accurate and very concise for you guys. That way you just have a super easy resource to access if you're in a jam. So, all right, guys. Well, Aaron, it was great seeing you too, buddy. It's Sunday afternoon. Cheers. Go enjoy your afternoon there in Australia. You guys, I'm going to do my best to get this stuff back on Patreon. I've kind of been through the ringer lately. Maybe I'll tell you guys more about it later. I'm happy to be back. Happy to be making content. I'm thankful that you guys decided to join me here tonight, and we will see you guys in the next one. Later, guys.